I'm going to show you how to measure a resistance with a digital multimeter. Digital multimeter has a couple of functions. It can measure voltage if I set it over here. It can measure current if I set it over here. It can measure, actually, this can measure temperature if I have the right probe. But this is the one where we're going to be interested in today. We're going to be looking at resistance. And you can see all these different things. What this says is it can measure, if I set it here, it can measure up to 200 kiloohms, 200,000 ohms. So if I want to measure something that's maybe 100 kiloohms, I wouldn't set it here because I'd get an overflow. And I would set it here. What you want to do is you want to set it to the lowest setting that actually can measure that. Okay, let me show you what an overflow looks like. Right now, I'm just going to set it to 200 kiloohms. And I've got these two probes. I guess I need to pull that up just a tiny bit. And if you look at the screen there, it has one and a whole lot of spaces and a dot. That means it's bigger than we're measuring. Why? Because air has a huge resistance. So they're saying that the resistance between these two probes is greater than 200 kiloohms. It's even greater than 200 megaohms. Okay? If I touch them together, I should find a resistance that's 0.00. I apologize for the glare. I'll try to take care of that. Okay, I'm going to measure this. This is a resistor, and I'm going to try to measure this resistor. Okay, so what I do is I'm not too worried. Actually, if I put the probes down, the table is not a good conductor. You can't see it, but it's still overflow on that. So what I can do is I can hold that down like that, and I can hold this down like this, and you want to get a good contact. In fact, if I just do this, hold that one down carefully, and then hold this one, then what I end up, I see a 0.06 on the screen. I'll move that up a little bit. Hopefully, it's going to be hard to do. Okay, so 0.06 is what's showing on the screen. Well, I can probably do a little better. That means it's definitely less than 20 megaohms. So I'm going to click down and I'm going to see if I can read it on there, because I want the most precise measurement. Hey, 65.5 kiloohms. Okay. If I went down to here, 20 kiloohms, it would be an overflow. Okay, it'd be out of range. So I do that, and yep, there's that one space dot. That means overflow. So what you want is the lowest reading, which actually ends up being the most precise reading, the lowest setting that you can get a measurement on. Oh, and look at that. Something's different. I don't know if it's my fingers touching it. So I'm going to try to take one finger off of there. And that's 67.2 kiloohms. So that's how you measure it. This was 67.2 kiloohms. And I'm going to show you how to read these later on. But this is blue, gray. We start on the opposite side from the metallic color. Blue, gray, orange. And I would look up in a table what blue and gray and orange mean for the resistor color code. Let me do a different one. Okay, this one's red, red, black, starting from the end opposite the metallic color. And when I do that, I get 0. There we go. Oh, let me just do this so I get a little pressure on it. 0. I know that's not 0. So let me go to a lower setting. And when I get that connection, I'm going to try not to touch it with my finger, but if I have to, I'm going to try to make sure that I only touch it on one side with my finger. I'm getting 0.022, so I want to go down even more. So again, you go down to the lowest setting you can possibly get a reading on, and it says 22.2, and that range is 200 ohms, so it's 22.2 ohms. You could measure up to 200 ohms on that setting. 22.2 ohms. Okay, so that's how you measure resistance values using a multimeter. And by the way, these plugs, com means common. It's kind of a reference. And there's ohms there. So I plug that in for the resistance setting.